take 5, 7, T, I don't know. Okay, so I'm Group B, so let's talk through the questions that I had to do and hopefully explain something, but it's probably going to be wrong and I'll probably be shouted at by the rest of the class. That'll be fun for everyone, won't it? Right, so question 1 is trying to prove that the energy of one photon is 3 times 10 to the minus 19 joules. And you do this by simply using the equation E equals hc over lambda, and you can plug in the values given by plugging in the wavelength of the light that you're given, which is red light in this case. The next question is proving, figuring out the amount of photons needed to be given off when a laser is of 1 milliwatt. And since you're doing it within a second, it is just 1 millijoule. And, and so therefore we just divide 0.001, 1 millijoule, by 3 times 10 to the minus 19, which is the energy of the electron, of the photon that we just figured out, which then gets us 3 times 10 to the minus 15, rounded obviously, photons given off every second. The next question is explaining how energy levels work to help explain how photons are given off from atoms. So, energy levels almost work like shells. The energy levels closer to the atom, so really close, are of a lower energy level, and the ones which are further away are of a high energy level. What can happen is electrons orbiting an atom can absorb certain wavelengths of light, and then after a period of time they then start to release that energy that they've stored. When they release the energy, they release the same wavelength of light as they absorbed. So, for instance, helium obviously absorbed red light, so it then gives it off afterwards. And so as it releases that light, it then comes back down to its original energy level, which is why it actually releases it, because it wants to come back down to its stable form. The next question is explaining why blue light you need less photons of blue light to create the same amount of joules as that of red light. So you need less photons of blue light because blue light is of a higher frequency. And because it is of a higher frequency, it then means that you need less photons because it has more energy in it. Okay? That's the simple reason, really. The next question is a delightful diagram of a photodiode. Very fancy, very fancy. And it shows incident light hitting a surface, and it then wants you to show the electron flow towards it, because when the incident light hits the surface, electrons are released from there, causing it to have a positive charge, therefore electrons will flow towards it. The question after that is trying to calculate the current in the circuit created by that. So for this you want to use the equation I equals NE. So, but in this case only 20% of the photons hitting are actually releasing an electron, so you want to multiply that by 0.2. So we do 3 times 10 to the 15 times 1.6 times 10 to the minus 19 by 0 times 0.2, which equals 9.6 times 10 to the minus 5 as the current in the circuit. And then the final question is suggest one reason why the efficiency of the photodiode is less than 100%, and one of the answers is just because some of the photons just don't have the threshold voltage needed to, threshold energy, to release an electron, meaning that only 20% of the photons have the energy required, therefore only 20% of the electrons actually get released. And that was my video. Hope you liked it. Hope I didn't bore you. Hope it was correct. Right, see you in the lesson.